Hi, and welcome to the tutorial video for AutoGaitA DeepLabCut. Please note that there are separate videos for file preparation and for the advanced configuration of our DeepLabCut toolbox. However, given that you've prepared your files accordingly, we can run the main analysis via first entering the sampling rate of our videos in Hertz, meaning how many frames did you have in a second. Then you have to choose whether you want pixels to be converted to millimeters. And if you would like to do that, we need to know how many pixels equal a millimeter in your case. Then you can choose to standardize y coordinates to a beam or to baseline height, which needs to be tracked. So for us, that looks like this, and this is just the data that we also put in the example data folder of our repository. So you can see our mice are working from left to right in this case, and we have a beam that we track here. And that just gives you more accurate height standardization. However, note that if you should not have a beam that you track, your height values are still standardized either to the global minimum of a given video or to a joint that you can choose, but that's in the advanced configuration. Next, you have to choose whether you want x coordinates to follow the direction of movement. And this means that if you should have animals that walk through the video frame from right to left instead of from left to right, we simulate that they walked from left to right. So this just ensures that all x coordinates can be compared across animals, and importantly, all velocities can be compared across animals. So if you have an experimental setup as we have here with, for example, mouse locomotion, just going through the video frame, then I would recommend you to tick this box. However, if you should, for example, look at treadmill walking, for example, where the animals are roughly on the same position of your video frame, then I would not tick this box, because then our adjustment might do some funny things with your x coordinates. So if you should have any experiment where animals' position doesn't really change, whether that's treadmill walking or maybe I don't know, rope pulling or air walking, then I would recommend you to not use this option. Next, you can choose to not show the plots in the figure GUI. And finally, you have to tell us how many bins you want to use for step cycle normalization. So this is the value to which we normalize your step cycles, meaning concretely that if step cycles should have been shorter in your videos, we duplicate values until we reach this value. And if step cycles should be longer in reality, then we average neighboring values of a given column until this value is matched. So let's give an example. For example, if your step cycle, so this is an extreme example, but just because I think it works well, imagine that your step cycle was just 5 time points long. Then we would take each time point 5 times. So we would go time point 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, and so on until we have 25 values. And if the next step cycle should be of length 50, then we would average neighboring values. And with neighboring, I mean neighboring in time, so temporally adjacent values until we reach this value. So for 50, that would be we take time point 1 and 2 for, let's say, the ankle y coordinate. We take time point 1 and 2, average that, and that will be the value of the ankle y coordinate of the normalized step cycle. Then we go to time point 3 and 4, average those, and put that in the second bin of our normalized step cycle, and so on. As I said, for joints and angles customization, advanced configuration, there are separate videos. Now we want to just analyze one video. For that, we have to say what is the number of the animal we want to analyze, what's the number of the trial we want to analyze, where is our data, what's the name of the annotation table, and then according to the file naming convention, what are the identifiers. So what's the identifier differentiating body track coordinates from beam or baseline track coordinates, and then what is the unique subject identifier, task identifier, trial identifier, and camera identifier. So if we look at our files on the left here, what is the identifier before the animal number? For us, that's mouse, so that is B. What is the identifier after the animal number? For us, that's 25 millimeters, that's C. And then what is the identifier before the trial number? That's run for us. And the unique camera identifier coming after the run number for us is 60LC. Okay, now we can run, and because we didn't tick this box, we can get our results in this nice figure GUI here. So now we can just scroll through and check out our results, check out the stick diagrams. So this is just for individual step cycles, of course, and then we get also some figures for the average step cycle. So after averaging the 3 step cycles of this given video, what were joint heights over the average step cycle going from 0 to 100%. Last thing I want to show you is this batch analysis button, where you can, it's pretty much like the single video button. However, you don't have the first 2 boxes, because here you just need to know where the folder is, because for the batch analysis, AutoGaitA just scans through a given folder and automatically finds your data and automatically just scans through and analyzes it. I just had to look, wait, let's tick this box, because otherwise we get a figure GUI for each video and we don't want that. We enter the information as we did just now, we hit run, and then even though we don't get a figure GUI, we still get the information of individual videos if there was something wrong. For example, here there was no step cycles in the annotation table, or if we did the flipping, such as for 13.1, and so on.